Okay. We don't have time in the curriculum to go over Chapter 1 notes. This is just a review for you anyway. So I thought I would videotape them, and if you need the support, it will be on the website. Okay. In chemistry, we're dealing with the very, very large numbers and very, very small numbers and measurements. We need to recall that a measurement must have a number and it must contain a unit. There are two types of numbers. There are exact numbers, also known as counted or defined numbers. Here's an example. A dozen is always 12, and it is an exact number. An exact number is not something that you measured. It's already defined for you. When you're talking about a percentage, you're always talking about out of 100%. That is an exact number as well. However, if you were talking about a measured quantity, I am 5'5" and 1/4 inches tall. I know that because I measured myself. That is an inexact number. If I wanted to convert my measurement from inches, feet, and inches into centimeters, the conversion factor, 1 inch is equal to 2.54 centimeters, would be an exact number. You need to be able to convert from one metric unit to another. Here are the prefixes and the symbols for those prefixes. The base unit is meter, liter, and gram. The most commonly used prefixes are the kilo, the centi, and the milli. Micro is something that you would see if you were a pharmacist. If you take vitamins, some of your vitamins will be in terms of micrograms. Some antibiotics are also measured in that quantity. Most people have heard of the prefix nano when we're talking about nanotechnology. It is a defined measurement. 1 meter has 1 times 10 to the 9th nanometers. A nanometer is very, very small. I think you remember when you were in Chem 1 that we used a mnemonic. King Henry died by drinking chocolate milk. This mnemonic stood for the prefixes kilo, hecto, which is not used very often, deca, also not used very often, base, meter, liter, and gram, centi, and milli. If you start out with milliliters and you would like to know how many kiloliters that is, you would move the decimal in your milliliter 1, 2, 3, 4, 5, 6 places to the left. One of the things that is important when we're talking about measured quantities are significant figures. Significant figures tell you how sure someone is about a measurement. If you measured me just by looking at me, that would not be a very sure measurement. You would not put a whole lot of significant figures there because you really didn't measure precisely. If, on the other hand, you use a measuring tape, you would use more significant figures. You're sure of more of my feet and inches when you use the measuring device. So, there are rules for counting significant figures. I won't belabor them, but they are very important in science because they tell you how closely and accurately someone's measurements are. Did they eyeball it, or did they use a very precise measuring instrument? Here we go. There are a few rules. Non-zero integers are always significant. Okay, here are some examples. These are all non-zero integers. All of them are significant. This number has 3 because it has 3 non-zero integers. This number, 1.9432, has 5 significant figures. Leading zeros are never significant. Leading zeros are never significant. These are no more than placeholders. The only significant figures here are the 3 and the 4. Captive zeros, always significant. So there are 3 here and 4 significant figures here. Trailing zeros are irritatingly odd. Trailing zeros are only significant if the number contains a decimal point. I spy a decimal point, therefore all the trailing zeros are significant. I do not see a decimal, therefore none are significant. What I see here are a mix of leading and trailing zeros. Still never significant, even if there is a decimal. This becomes significant because there is a decimal. There are 4 sig figs. Now you're going to have to be doing manipulations of numbers, and you're going to have to keep track of significant figures when you do mathematical operations. Let's talk about multiplication and division. Very easy. The number of sig figs is the same as the least precise measurement used in the calculation. So here we have 4 significant figures here, 3 significant figures here. 3 is less precise than 4, therefore your answer can only have 3. So you take what your calculator spits out and you round up. So counting from the left, you know you're allowed 1, 2, 3 significant figures. Stop here. The one next to the last significant figure influences what you do to the last significant figure. It is over 5, so you round up. Okay, exact numbers don't affect the number of significant figures. The number of significant figures a number should have. Okay, scientific notation is going to help you deal with really small and really large numbers in calculations. Okay. There are 3 parts: the coefficient, the numbers before the x, all of these are significant, the base, and the exponent. All right. The coefficient must be greater than 1 and less than 10. The base must be 10, and the exponent shows the number of times the decimal was moved in order to get the number into scientific notation. What you should take out of this is there's always a decimal after the first integer in scientific notation. All right, unhelpfully this is wrong, so I've corrected it. Okay, if I take this number, 10,500, and put it into scientific notation, I know that the decimal started off here and must be moved here after the first integer. So that would be 1, 2, 3, 4 places to the left. If I move the decimal to the left, the exponent is positive. The way that I look at it, the way I always remember it, is I needed to make 10,500 much smaller. I made it 1.05. If I make the coefficient smaller, I need to make the exponent larger. Okay. Please read the rounding rules. You are going to need dimensional analysis here quite often. So I would like you to use the factor label method, dimensional analysis, all the same. You write the original number. Let's look right here. A pencil is 7 inches long, starting with your original number in unit. Multiply by a factor with the unit to be discarded on the bottom and the unit that you want on the top. The question is, here is a pencil is 7 inches long. What's its length in centimeters? Here's your conversion factor. So 7 inches is what we start with. So what you start with goes on the bottom, what you want goes on the top. These units will cancel out, leaving you with your desired unit centimeters. Multiply everything on the top, divided by the quantity, everything on the bottom. Precision and accuracy have very specific meanings in science. Accuracy means correctness. You're going for 100% accuracy on your test, you get 100. It means the agreement of a measurement with a true value. If the true value is 97 and you get 97, you are accurate. Precision is nothing more than reproducibility. If you were playing pin the tail on the donkey and you pin the tail on the donkey's shoulder 6 times, you are very precise, but you are not very accurate. Okay, random error means that error just happened all over the place. Here's some random error here. Systemic or determinant error means that your error is skewed in one direction or the other. Okay, moving on. Density is a ratio of mass to volume. High density, a lot of mass in a small area. It's a physical property of a substance. It is extensive in that it depends, mass is extensive because it matters how much you have. Volume is extensive because it matters how much you have. However, density itself is intensive because it is made from 2 extensive properties. I think I need to spend 47 seconds on talking about the state of matter. I believe you know what the state of matter. Solids, liquids, and gases. Here we go. Here's a picture of some solid, liquid, and gases. I would like you to notice the spacing. It's all about the spacing. Okay. Back to this. Okay. Properties on a macroscopic
Attention
level.
teachers, I'm getting ready to go to the book room and distribute books to the following subjects: foreign language, PACE, college prep, fine arts, health, and PE. I'll be in book room 1 from 1 to 1:30 to distribute your books. Please bring a card. If not, I have a few
You might be
available.
able to hear the announcement. This is a good time to say you need to pick up your advanced placement chemistry book from the library as soon as possible. There will be material that you are tested on that's in the book that I will not be covering in class. You are responsible for it. Here we go, the classification of matter. Matter can be subdivided. Matter, remember, anything that has mass, it takes up space. It can be divided into pure substances. Pure substances are made up of elements and compounds, or mixtures. Homogeneous mixtures, which you know as a solution, or heterogeneous mixtures, which are the other type of mixtures. Let's see if we can look at a picture of heterogeneous matter. The AP College Board has a really vested interest in these particle diagrams. You need to be able to work with particle diagrams and identify what's going on just by the particulate view. All right, here we go. We have pure water. We see compounds. They are chemically bonded together. Here are helium atoms, only one type of pure substance. It's an element, cannot be broken down. Here is a homogeneous substance, and here is a heterogeneous substance. Okay, I would like you to look at the PowerPoint that will be on the website. It shows pictures and different ways of physically separating mixtures. I think what you need to get out of this is to remember that mixtures can be separated by physical means. Substances cannot be separated by physical means. Here are some physical means of separation. Next week we'll be doing a lab on chromatography. Okay. Please read chapter 1.